Okay, we're down now in the control room for the wind turbine, and as you can see here we have two inverters, two Windy-by inverters. They're grid tie inverters, and they're 2.5 kilowatts, and both of those combined will give you a total of 5 kilowatts of power. The controller for the wind turbine is here. First dial here reads the voltage that it's coming in. It's wild AC, so it could be anything from 2 to 400. And the bottom one here just reads amps, the amount of current that is available to use. That fluctuates up and down depending on what voltage is there. So today now we're reading going on to 5 amps there. It's not a hugely windy day, but it will fluctuate up and down, as you'll probably see throughout the video. The cable coming in from the turbine enters into this controller here, and it's changed from wild AC into a DC current that is pushed through these inverters. And from these inverters then, these are the brains behind the whole operation. The inverter current down to 230 volts, so we can use it in the house. These items here are regulations, they're isolators, things that you need. At the moment now we're reading 15 amps there, so the wind is blowing pretty heavy out there. These are fuses, control fuses, and this thing here will tell us how many units of electricity we're going to have throughout the year. So at the moment we're reading 345 units. So it has produced 345 kilowatt hours of power since it has been installed just less than 6 weeks ago. I'm hoping that the last 2 or 3 weeks haven't been great for wind, but today now is exceptionally good, and we're hoping that January, February, March, that the winds will pick up. Our site is reasonably good, but it could be better, it could be higher. Basically that's all that's involved with it. It's grid tied into the mains, so that when the inverters see the mains current coming in from this cable here, the turbines are active with this green light. If for any reason the ESP drops out or the power drops out, we'll simulate that happening now in a few minutes, but if it does happen, it jumps down into a failure. So it automatically means that the turbine cuts off, not to be kicking power back out onto the grid. So if I go over to my fuse box, which is behind me here, and I knock down the power, they automatically go down into a failure light, and the turbines now are inactive, and the turbine itself is inactive. And you can see that clearly there by the ampage. It's not producing any current to go into the house or any turbine power going out onto the grid. So that's a very important part of what these turbines do when you're grid tying. I'm just going to put it back into simulation again. It takes some time for them to come back online, because they have to recognise that power that's after coming back onto from the ESP, and it goes through a sequence of programming, and once it establishes that the power is there the whole time, it will go back into turbine mode, which will be clearly indicated on the little legends here when it's active. It's registering at the moment now by the flashing lights, and it's programming itself to go back into mode turbine, and that should happen very shortly. And when that happens, then our amp meter registers, and it's just about to move there now. We'll start seeing some current being produced. It's still mode waiting, so it does take a few minutes. There's not an awful lot else we can tell you about this system, other than you don't have any batteries with it, and you don't have any maintenance on it. Anything that goes on inside here, it just does its own thing. It's absolutely foolproof. Once it's installed, there's no maintenance on it. If you had an off-grid system with a battery bank, you'd have a lot more care and maintenance of the batteries, and you'd need to be given a lot more time and watching for any defects. But at the moment, this is the system that we're going to market, and it's a grid tie, completely grid tied, and its settings are to an EN 50438, which is regulation by the ESP, and it's very important that the actual settings are correctly installed on the inverters. It's something that we do as a company, and we have permission from Windy-by to make the adjustments on these turbine inverters to comply with the EN 50438 settings. And once you have your turbine set up and running, there's really very little maintenance with it. Once a year possibly you would have to call us out to maybe do a little bit of work on the actual greasing of the nipples and things on the turbine itself, but I expect that maybe once every 2 years we'll possibly do too. It depends, I suppose, on how many kilowatt hours it is running. If it's running pretty hefty and producing a lot of power, you would be as well off to get it done yearly. It's not going to cost an awful lot of money to get the tower brought down and to do that little bit of maintenance. And anytime you do a little bit of maintenance on it, it always helps to keep it turbine going and keep the lifespan of it, which is about 20-25 years it should last. So as long as you keep the turbine service regular, it should give you no trouble. These turbines are installed 40 or more above in the north of Ireland, and there is over 180 installs done in England. It's relatively new to this country, Southern Ireland, and I believe this is the first one down south, so there is another one belonging to Anthony Fowley in Cavan that we installed there just before Christmas, but that particular turbine would be on a far better site than the turbine here. We'll keep in touch with Anthony and see what his kilowatt hours are, and I'm sure he'll be producing more current than I will, but we both bounce off one another and we keep them figures for you on the site, so if you want to update or if you want to keep in touch with us on the site, we'll be able to tell you what kind of kilowatt hours the